ENCOR Section 16 Summary Challenge: Wireless Roaming and Location Services. Which type of scanning occurs when the wireless client changes to 802.11 radio channel and waits for a periodic beacon from any APs on that channel? That is passive scanning. Okay? That's what it's called, passive scanning. Which three items remain the same when wireless clients do intercontroller layer 2 roaming? Okay, which three items remain the same during the intercontroller layer 2 roaming? Okay, so SSID remains the same for the client, and VLAN also remains the same. Point of attachment actually does change because the client was handed over not just from one access point to another, but also between wireless LAN controllers, right? So between two different access points, which belong to two different controllers. So this will change. IP address of the client will remain the same. And that actually applies to all implementations of roaming. Data usage. Will it remain the same? Probably remain the same when wireless clients do intercontroller layer 2 roaming. That's a weird item to have here. I'm not sure about data usage. Okay. The wireless client's location. The wireless client's location definitely changes. That's the whole point of roaming. However, I'm not sure actually about VLAN, because VLAN, no, it remains the same, right? VLAN may change or would change if we would do layer 3 roaming, which is similar to layer 2, but only client is moved from one VLAN to another, or one IP subnet to another, while both subnets or VLANs belong to the same SSID. So I'm really not sure about this data usage option here. What does it mean at all? Will data usage remain the same during roaming? Well, I guess, I don't know. It's a statistical value, right? Okay, let's keep it like that. Which item remains the same when wireless clients do layer 3 roaming? Okay, let's see. The controller for the client point of attachment. No, controller for the client point of attachment does change. The client database of the new access point. The client database of the new access point? No, it does change, because the access point, the new access point, should kind of learn about the new client coming into the range of this access point. The client POP, that's what remains the same. POP stands for point of presence, and in layer 3 roaming, it's a little bit weird how it works. So one controller hands over the client to another controller, but the new controller still maintains the link to the original controller related to that client. So both controllers will keep records about this client in their client database. However, in the original controller database, it will be marked as anchored, maybe. I think it's called anchored. And on the new controller, it will be marked as foreign. And what these two controllers will do, they will tunnel, the new controller will receive traffic from the client and tunnel all Discord traffic into the original controller. And this original controller will then further process this traffic, for example, pass it to the wired network or anything else. Okay, and the last option, the client data traffic. Which item remains the same? I'm not sure what they are trying to ask here. The client data traffic, will it remain the same? But anyway, I think the client POP is the correct answer. In which three cases should auto-anchor mobility be implemented? Okay, so auto-anchor mobility is for guest users which may roam around our internetwork and around our building and or campus. But what we want to have for all guest clients is to be anchored to just one single, possibly even dedicated wireless LAN controller. So the POP, the point of presence for all the guest clients, would be on just one controller. Point of attachment may change over time as they roam around the site, but POP will remain the same. Let's see the answers. Limit guest access to the corporate network by first parsing the traffic through the corporate firewall. And this is a correct option because all guest traffic is consolidated into one wireless controller, even if other wireless controllers are involved as points of attachment. Kind of all guest traffic is just centralized into one place, which makes it a perfect place to put a corporate firewall. Limit the APs in which guest access is permitted. Limit the access points in which guest access is permitted. Probably not. Access points will do not need to be limited, I guess. Well, let's keep this option as tentative for now. Implement a geographic access policy that can restrain client traffic to a specific subnetwork. Could be as well. It's a good option, actually. Depending on where the client is located geographically, they can be restrained, right? And they can be put into the specific subnet. Change roaming characteristics if a firewall prevents layer 3 roaming from functioning properly. Changing roaming characteristics to circumvent some issues with layer 3 routing caused by a firewall doesn't sound like a good idea at all. So that option doesn't make any sense. Limit guest access to the corporate network by blocking traffic before the corporate firewall. Probably yes, and this resonates with option number 1 here as well, right? So we have all guest traffic consolidated into one place, and then we have a firewall and kind of block this traffic to even from entering the corporate firewall and corporate network subsequently. Discourage guests from roaming, that's not a good idea. People will be roaming anyway, right? You cannot discourage humans from roaming around. This is in our nature. Which 3 features are associated with Cisco CMX? CMX stands for Cisco Mobility Experience. And the features are 3 features. Okay, so what it can do detect, engage, and connect. So these 3 features. The first one is detect, is basically to see if user is there in, let's say, a floor or in a range of an access point, right? In a specific kind of area of your premise, right? The second one is connect. That's providing user with a captive portal with a splash screen, maybe some special offers, or maybe a capability to authenticate with SMS, email, or social network account. And third is engage. By collecting this data, you are able to engage with these users. And I think even through the CMX, you can even do some engagement in terms of offering users some coupons or things like that when they connect to Wi-Fi. Presence and location are kind of two two tiers or two levels of engagement for all these three options. So presence is just if the presence is detected of a client in a specific location, not in a very specific location, but it's in a certain area. That's better said this way. In a certain area, right? It's there or it's not there, which gives you kind of enough data to do some processing and some analytics. And location is further than that. User location in a room can be more or less accurately determined by triangulation, I guess, and then these data can be even further helpful, right? So location is more advanced than presence, but all of these, or these two, presence and location, are kind of are different levels within the detect feature, right? So detect can be presence, which is basic, or location, which is more advanced, more rich. Which two features are associated with location-based services only? Okay, location-based services, that's what is more advanced, right? As opposed to the presence. Analytics. Well, analytics can be done with even with the presence. Just knowing users coming and going, analyzing the time users are coming and going, and so on. So this is not a correct option, I guess. Correlation is probably a good option. If I'm not wrong, correlation is analyzing users' paths through premises, right? Where users are located in which moment of time. And thus you can analyze how people are basically moving around your premise. Dwell time is definitely the basic because you can capture the moment of time when user appeared in an area, and then capture the moment of time when user left the area. And this time length will be the dwelling time. This can be analyzed. Heat maps. Heat maps definitely is a good option here. Because they build more or less precise heat map where users spend more time on the premise. And finally, conversion rate. Conversion rate. Not sure about the conversion rate, but I think that conversion rate can also be done with just the presence-based services. So you can see that user is appearing, and then something happens, right? Something, let's say, users are accepting a coupon which was offered to him when the user connected to Wi-Fi. So something like that. So I think these two options are right. And finally, which two options describe the use case and minimum number of APs that are needed to support 20 meters of location accuracy? 20 meters of location accuracy. So I think 20 meters, as I recall the accuracy table, is the most basic. It's the simplest location accuracy, which pretty much equal to just presence, right? So the client is present within a range of an access point, and this is 20 meters accuracy. And to enable that, to have that, you just need one AP, okay? You do not need 3 APs, and you do not need map integration. Venue level, visitors, and dwell time. Yes, probably this is a good option as well, because visitors can be counted. Dwell time can be calculated for the visitors, and venue level can be determined. I mean, I assume here venue level means basically the floor of the building, right? And with just basic 20-meter accuracy, you are able to determine on which floor users are located. Zone level correlation. Correlation needs more accuracy. Modular APs with hyperlocation modules and antennas. These are used for the highest, most accurate level of location services. And they require specific modules being installed. And as I understand, these modules, they work kind of mostly, however, they probably talk with the AP itself in some way, but primarily they kind of can do their job without any need to load the access point radio itself, right? So they do not rely at least as much on the access point logic itself and its radios. They have radio they can scan, like for example, they can scan all the channels at the same time and things like that. And subzone level navigation, that's definitely also for more accurate level of service. So these two options are good. Let's see. Okay, there was one mistake. I will review and see where I was wrong. And of course, the error is in the question I struggled the most with. In which three cases should auto anchor mobility be implemented? So these two options are correct. And the last one, I first checked this one, limit guest access to the corporate network. However, the correct option is this: change roaming characteristics if a firewall prevents layer 3 roaming from functioning properly. I checked the course content and it is exactly as it is written in the course. I cannot say that I fully understand the idea or why, what it particularly means. Change roaming characteristics if a firewall prevents layer 3 roaming from functioning properly. I don't know. I can only imagine. It doesn't go. It's pretty generic, right? It doesn't go into detail of explaining that. That's why it's a little bit difficult to properly grasp. But what I could imagine is, like for example, firewalling. So if we have the auto anchor, so that means all the guest users are just going to one controller and they can be handled by a firewall just in this central location. If we don't do that and we just do this, just a simple or like normal layer 3 roaming, that means that the user's traffic is tunneled to the original controller, and some firewall policies could be applied to impede this process. So I can only vaguely guess about this, but anyway, so this is the correct answer.